You're listening to MedX, the Medical Extrusion Podcast. Presented by U.S. Extruders. Extrude with confidence. Custom extrusion equipment designed for you and your application.
Hello, everyone. Welcome back to the MedX Podcast. I'm Steve Maxon. Today's discussion is focused on medical tubing and polyimide tubing, and our guest is Adam Sutton, founder and CEO of Keystone Medical Technologies, based in Somerset, Wisconsin. Keystone Medical Technologies is a custom manufacturer of thermoplastic medical tubing and thermoset polyimide tubing. Adam, I've been trying to get you on the podcast for a long time now. Thanks for finally carving out some time to join us.
Absolutely, Steve. I appreciate you having me today.
Great. And everybody likes a good entrepreneurial story, right? So let's talk about how for 16 years you were a very successful manufacturer's representative for some of the leading medical device component manufacturers and contract manufacturers. Tell us about your decision to enter into your own business, extruding medical tubing and polyimide tubing.
Yeah, as you mentioned, represented some of the well-established component manufacturers in this space, and throughout the years, I've been very hands-on as a rep, and probably did a lot of things above and beyond what most manufacturers reps do. So as the years went on, I was like, why don't I just do this myself, and gained a lot of knowledge, obviously from a business side of it, but also technically. And throughout those 16 years, I also did have ownership stakes in some companies, med device related. So I did have some experience, being inside, but it kind of happened. I don't want to say there was an aha moment, but it was just as the years dragged on, and it was a good time to do it here. And coming out of COVID has really worked out well with supply chain issues. It's allowed a smaller company like ours to compete. When some of the bigger players are struggling with lead times, we've been able to carve out a little niche on being a little more faster turn.
Yeah. Okay. That makes sense.
Absolutely. Yeah.
I know that you have a partnership with Chamfer, the online marketplace for medical device components. And I see that you have hundreds of SKUs on the marketplace of medical tubing, from your common reflow type materials such as PBAX, nylon, TPU, and also polyethylene and polyimide. I also noticed, though, that you have many SKUs from low friction compounds with additives such as Propel from Foster and Mobilize from Compounding Solutions. And I'm just curious, because I know a lot of folks are trying to evaluate alternatives to PTFE because of supply chain issues. Are you doing a lot of development in that area?
Yes, we are. And I appreciate you bringing up our Chamfer partnership. It's working out very well for us. I think we are over now 200 SKUs, and we're adding, dozens every month. But to your question, yes, that's been a lot of our extrusion work is some of these low friction applications. Some as just as liners, 1 to 2.5 thou walls. Some a little thicker, but that's been a big area of our expansion and growth in our extrusion side of the business is running, Propel or Mobilize tubing. Again, like I said, a lot of times, for liners, so engineers can get going, so they can get started on a catheter project. And we found in many of these applications that it's working suffice for what they need, and we've actually begun to get spec'd in on some projects, moving into pilot production using either, it's usually 55, 63, or 72D PBAX with either Propel or Mobilize. So it's definitely been again, as I mentioned, coming out of COVID, and some of the issues with PTFE and the longer lead times. That's been a big part of our extrusion business is running these low friction type applications. Again, a lot of times for liners.
Yeah, that's interesting. If you could, if certain applications you could get away with a nylon or a P-Bax, often when you see PTFE, etch PTFE, you might have to have a tie layer or a strike layer for better bonding with the outside jacket materials.
Right.
And, with a nylon based or a P-Bax based, you don't have to, you have a little bit lower profile. And I guess you don't have to worry about, bonding between the inner liner and the outside jacket materials. You'll have a strong thermal bond.
Yeah, absolutely. Absolutely.
Okay. All right. So let's talk about polyimide tubing. Very interested in, we haven't had podcasts related to polyimide, so I'm very excited to talk about it. And just for background purposes, for folks that aren't aware, polyimide is a thermoset, and polyimide tubing is produced through a film cast solution process, not a melt extrusion process. And that allows for very thin wall thicknesses, very tiny diameters, and super tight tolerances. We'll get more into some of the specifics later, but I just wanted to give a background. But before we get into some of those details, tell our listeners about your decision to enter the polyimide tubing market.
Yeah. Again, as we discussed earlier, my years of being a manufacturer's rep, I repped a few different polyimide contract manufacturers, and I was a small owner in one of them, MWC Technologies, and just gained knowledge on the polyimide process and the business side of it. And there aren't that many people doing it. All the ones that do it are kind of these large conglomerates, and it was again thought it was a good thing to partner with the extrusion. There aren't any real small companies doing both tubing competencies under one roof. It's a good thing to partner with the thermoplastic extrusion business, and we do have some applications where we utilize both tubing processes on the same application.
Yeah, you mentioned under the same roof, and from my experience, the folks that are involved with thermoplastic medical tubing and a thermoset process, whether it be silicone or polyimide, usually separate, because it's different processes, usually different buildings or different locations. As you grow, and it sounds like you are growing pretty rapidly, will you separate those two competencies?
Yeah, so in the near future, we will look to separate the two different tubing processes. Because as you mentioned, Steve, they are very different, and there really is no overlap on our technical side of it between the extrusion and the polyimide. We have guys that do the extrusion, and we have guys that do the polyimide.
Okay. Let's get into some of the technical or unique physical properties of polyimide that make it one of the gold standards for composite catheter shafts. Tell us a little bit about some of those physical properties.
It's got very good mechanical properties, has very good scrape resistance, column strength, torqueability, and it's chemically inert, can withstand high temperatures because it's a high temp material thermoset. Mm-hmm. It's a very, very interesting material.
I think it might, correct me if I'm wrong, might have the highest tensile modulus of any.
Yes, I was searching for tensile strength. Yes, okay. Yes, it does. It has very good, very high tensile strength as well.
Even higher than peak.
Yes, I believe so.
Let's talk a little bit about some of the applications that polyimide is used. And I was wondering if polyimide is often used as a liner for inner lumens. And so why would you use it for a liner?
Yes, it is. It's used oftentimes for a guide wire lumen or other, type small lumen in a catheter. Reasons to use it: you can get very thin, sub 1 thou walls, depending on the overall diameter. But it being that small, it's again because of the tensile strength and column strength, you can push it very easily. Very tight tolerances, again, depending on the diameter, you're looking at plus or minus 0.0002. you can have doped polyimide, with PTFE that increases the lubricity, compared to like just normal polyimide.
Mhm.
So if you look at like the coefficient of friction of polyimide and PTFE, this kind of blended material is in the middle, but closer to PTFE than it is polyimide. So definitely, when customers are open to using that, most of the time I would say it's more than lubricious enough for their application.
Okay. Speaking of applications, recently I was manipulating a carotid self-expanding stent delivery system, and through the proximal handle, I was manipulating the retention sheath that contains the crimped nitinol stent. And it's amazing. I think it was like a five French device, and
Okay.
crimping that stent down to such a small diameter and loading it into that sheath and adjusting the proximal handle, the sheath retracted and the stent was deployed, which was pretty cool. But I noticed that the maybe 2-3 inch long retaining sheath was amber. That sure looked like polyimide to me.
Mm-hmm.
Earlier, you mentioned column strength, scratch resistance, and I'm just wondering because depending on the crimp force, loading that stent in the sheath, is that why you would see a polyimide sheet because of its column strength and scratch resistance?
Yes, absolutely. And again, you can achieve all that doing a very thin wall, so it's just going to take up less real estate in the catheter, the wall construction. The finish of polyimide is also fairly smooth, so when you're putting that stent through there, it's not going to snag up on the material because it's not a soft kind of tacky material. So definitely the smoothness of polyimide would be an advantage as well.
Okay, makes sense. So talk a little bit about the in general the wall thicknesses, how thin that you get on polyimide tubing.
If you're looking at kind of sub 20 thou, give or take, you can get down into the half a thou, so 0.0005 wall thickness. 7/10 walls are pretty common, again up to a certain diameter. We run generally a lot of 1 thou thick material. That just seems to kind of be the sweet spot for engineers. In a lot of polyimide applications, it's 1 thou, maybe 1.25, 1.5. You can certainly go thicker, but definitely in that 1 thou range seems to be a very common wall thickness for the polyimide applications that we run.
Is it provided in bare tubing, but is it also provided over a wire?
We could supply it over a wire because in our process it's all done over copper, so we could certainly provide that as like insulated wire, if you will.
Okay. You mentioned earlier about the capability to have a polyimide PTFE blend, and the PTFE is to reduce the coefficient of friction. You spoke about that.
Yes.
Do you also have the ability to put a strike layer or a top coat over the polyimide for better bonding with the other substrates?
Yes, absolutely. We do that. Common, materials like a 55 DP back, 72 DP back. We've done a 35 DP back. You can do Ticoflex, Ticothanes. There's a lot of materials you can use, but those are kind of the common ones too, as a tie layer. And we can do that either. We can do that either, through the film cast process, or we just ran an application where we actually extruded a little thicker layer, not thick, still sub 1 thou, but we actually just ran it through the crosshead and extruded it right on top of the polyimide.
Okay, that was my next question. If it's through a film cast process or an extrusion process, sounds like it's either one.
Yeah. Yes. Yep. Absolutely. Generally, we'll do it film cast because the customer just wants it there for bonding purposes, and so they want a couple tenths, maybe to a half thou. That'll be a film cast process.
Oh, okay.
Yeah.
Interesting. So then, with the blend, just an example of the blend of the polyimide and PTFE with a top coat of whatever material, nylon, PBAX, TPU, you could really provide a true composite construction.
Yes, absolutely. Yep.
Interesting.
Yep.
Hey, Adam, this has been a great discussion. I think our listeners will be very interested in listening about polyimide. I remember, years back going to, the medical shows and MD&M West and many years ago and walking by a booth that had beautiful pictures of reinforced shafts and there was an amber color. And the third day of MD&M West, that's when you can kind of go around and as a salesperson and do some things and walking up to the individual in that booth and saying, hey, I sell extruders. Do you get involved with extrusion? Him just kind of looking at me like he's been asked that question so many times. Like, no, that's not how we do this.
Yeah.
It's a different
it's a totally different process. But and yes, the tubes are pretty.
Yeah.
You get some, nice amber colored polyimide applications. They are pretty to look at. So
speaking of that, are there different colors added, or is it pretty much
you can add
amber?
Well, that is the the natural color, and as you get a thicker wall, it'll get a little darker. It's just passes more build. It'll kind of get a little darker brown, if you will. But you can add colors to it. You either get a premix or you can get dyes and mix it in yourself. Green's pretty popular. Black's another one. Red, but generally, most people. Amber is the color. I think it's just what they're used to. So, but there are applications, like I said, where there will be some colors that you can add to the material. So,
okay. Hey, Adam, this has been a great discussion. Thanks a lot for joining us.
Absolutely, thanks, Steve.
All right.
Thank you for listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. All links are available in the show notes.